afternoon, everybody, and welcome to Zahn Academy. Today's program is A Technician's Experience, how Trusana and 3D printers are changing the digital landscape. Today, we're honored to have Kris Schermerhorn as our presenter. Kris is a CDT and owner of Northern Virginia Dental Lab. Kris has been a co-inventor and developer of many of Meyerson's materials and was named Inventor of the Year in 2007 by the NADL. Welcome, Kris, and thank you so much for joining us today. Enjoy, everybody.
Great, thanks a lot. Appreciate it. Yeah, so we're going to talk about Trusana. I think that we've really gotten the news out there. Got a lot of curiosity when it comes to Trusana, and I think now people are really starting to have information on kind of what the process is. You know, you've heard a lot about the chemistry and a lot about the strength and stuff, and we'll go over some of that today. But I think the real important thing that we're going to touch on today is going to be what a lab is going to do with this, right? When you make your teeth, how are you going to bond them to whichever base you decide to place them on? And I'll talk about some of the things that I'm doing in my lab. So it's going to be real life information. I'm sorry, give me seconds. I'm getting a battery warning, which is good. I got a battery warning. That's so funny because literally we were talking about a presentation 2 minutes before we got started when someone let their battery go, was plugged into the wrong port. I almost had the same thing happen. So yes, we are going to talk about the process and kind of real life usage of this material in the lab. So again, for people who haven't heard about the advantages of this material, one of the large concerns in our industry are absorption of moisture, right? These sit in as high a moisture environment as you could possibly imagine in the mouth. And so you can see here, a lot of the current materials available today have up to 2% absorption of moisture. With denture teeth, right, that we've been using for many, many years, which do well with not staining and having absorption of liquids, which comes with it, stains, bacteria, and smells, at 0.4%, which is good. The actual Trusana is less than that at 0.35%. So 4% is something we know works for us. Trusana is actually less than that. So that's a great thing. So yeah, you know, you don't have to worry, you know, and that's been the big concern with printed materials, even milled materials, right? I mean, a lot of the milled materials out there for denture teeth, they can only make them so hard so that the mills can actually deal with them, can actually mill those materials efficiently and accurately. And so it's been a concern that, you know, we love technology, but we don't want to jeopardize longevity of an appliance just because the technology of digital design is better. And so Trusana allows for that, right? It allows for a as good, if not better, you know, it's the word I'm looking for. It's chemistry, it's functionality, it's longevity. All those things are as good, if not better, than what we're already using. And that's refreshing because now we can use our technology and feel good about it, that we're giving something to the patient that's going to last longer. And so with Trusana, not only do you have its resistance from stain, which is that absorption of moisture, we also have its toughness, it's wear resistant. You're looking at, you know, 3 times the wear of a lot of materials, at least 3 times the resistance to wear of a lot of materials that we're putting in the mouth now. So again, as good, if not better, than what we know works, that we've been using all of our lives as dental technicians, most likely. So again, you can have that security and knowing that you can use that technology and you're not giving something that's less of a functioning appliance for the patient. One thing that was really interesting as I was learning about this material was a lot of materials that are processed today, 3D printing and beyond, but our real concern is kind of comparing to some 3D printing materials, actually dramatically lose strength as they sit in a high moisture environment. So you can kind of see that, this is a leading brand that was tested, is already much lower than Trusana from the start, but dramatically drops in its strength as it's saturated, as it sits in that high moisture environment. So it's a little misleading whenever they're advertising some of the characteristics of the material when, while that's done dry with the Trusana, as you can see, it does drop slightly, but just really not a noticeable amount in its strength. So again, we can make something with our technology that allows for us to design better and easier a denture and know that we're making it out of something that's a high quality, long lasting material. And so the wear resistance on this material, we had a company do testing, as you can see here, and this is an opposing and a zirconia crown. And they said, right, so you can see here, it's 2 times more wear resistant than the leading tooth brand. That's substantial, right? That's the leading tooth brand. That's choosing a denture tooth that's going to, it's a quality denture tooth. It's going to be resistant to wear. And Trusana's 2 times better wear rates. That company said they've never seen a plastic come back with this kind of resistance to wear. So, and this company is not just a dental related company. So again, very impressive. And you guys will, if you guys get this material, or if you've had it, you've started to grind on it. It grinds like a composite, right? You know how when you grind a composite, it's kind of dusty. The first thing I started doing when I did occlusal adjustments was use a carbide. And I'd go in there and I'd adjust cusps, and it was kind of whining on it. And it was kind of putting this dust off. And I learned real quickly that rubber wheels do a really good job, maybe actually a little better than the carbides, because the teeth of the carbide are trying to grab a chunk and take it off. That's what happens when you grind microscopically with a carbide, and it really just couldn't get the chunks that it wanted, and really wasn't removing the material like you wanted. So I found rubber wheels, rubber points do a pretty good job, or fine cross-cut carbides do a really nice job. And don't get me wrong, it's not like if your bite's off, or if for the doctor the bite's off, they're going to have to be grinding on this and it's like grinding on zirconia or something. It's not like that. It just grinds differently. So it's just a little bit of a change in what we do, but it shows that wear resistant, which is going to be great for patients in the mouth. And speaking of wear resistance, we started doing some studies. We're going to write a few papers on this in associates with Dr. Sadowski. He's working with a few prosthodontic schools. And what we're doing essentially is we're taking patients that are getting all-on-4 restorations. That's a huge problem in our industry now, or some places are doing these as final restorations. But the way we're going about it is as if it was a temporary solution while the patient heals, and then transitions into something more permanent. And we'll see with some of these studies, Trusana could be a permanent option as well. That's to be seen. But for right now, the study is the school makes a all-on X, right? All-on 4 or 5, 6, however many appliance, traditional, right? So there's acrylic, there's denture teeth, and it's screw retained directly to the multi-unit. Then they're scanning that. Once they get in place, any adjustments are done, it is the appliance that the patient's going to wear for this time period. They then will scan that. They will give me the models, and we are duplicating that appliance as exact as we possibly can. So we're printing it in Trusana monolithically, right? So all one piece, the tissue part, teeth, everything is all one piece. The only differentiation would be the multi-units are retrofitted in to the appliance at the lab. So we have a titanium interface. And so we're painting the tissue on with OptiGlaze, so the tissue is no different. We're polishing the occlusal surface. So, you know, of course, there's microscopically differences, but we are doing everything we possibly can to make it as exactly the same as the appliance the patient has in at that time. And then the patient wears that appliance for a set period of time, a few months. And that appliance that was acrylic and denture teeth comes out, and our appliance goes in made out of Trusana. And then the patient will wear that for the same amount of time, a few months. And then they will take those two appliances and they will do some testing to compare where they'll make note of chipping or breaking comparably. And so far, so really good. The Trusana's holding up really nicely in that circumstance. But this is really nice study that they're doing, because that is a really challenging appliance in our industry to make, because you're coming straight off the head of implants. It's as rigid as anything can be in the mouth. It's supporting a full arch. So if any of you guys have done any of those, you know that they can constantly come back with teeth blown off. You know, a lot of times you're doing metal strengtheners and stuff to try to support that appliance. And it's a challenge because you have multiple materials interacting with each other. With the Trusana, you have one material that is a very strong wear-resistant material. So I'm really excited to kind of really see how things are going, but I will tell you, I have several cases going and it's going well. A little information, we talked about Dr. Sadowski. He is monitoring and working with the universities and me and to get these appliances done, and he's going to will be monitoring the testing that is done between the appliances at the end. Dr. Stansberry is the mastermind behind the material, and has come up with a really outstanding material properties for our company. And then we have Dr. Ed Cabbage. He has his own company. He's the one who really is helping us to develop the validations for different printers and the the light curing of it and a lot of that different stuff. And then Stephanie, Dr. Stephanie, she is more working closely with Meyerson to support a lot of the stuff. She's a chemist and helps us with a lot more directly through Meyerson if we have any questions or anything as materials and things for this. So it's all a really great team that's already created the material, and then a great team that's supporting that material as we release it, as we get more printers validated, and so we can kind of continue on with this process of releasing this material and making sure that, I'm a technician. I have my own lab in Virginia. Whenever I went to buy my first mill, I researched the mills, but the second research I did was on the support for those mills. When I got my design software, the first thing was, what's a good design software to use? And then secondly, where do I get that software? Because I need really good support. And I think it's going to be the same thing with 3D printing and the materials. You're going to want to find a good material, but a good material is not much if it doesn't have a really good, solid company behind it that can support you as you learn and go through this process. So I think we got that here. I think you'll be in good shape. So that gives you kind of a baseline for the company. So let's get into the nitty gritty, the technician stuff. So what I'm going to take you through is the process that I go through, and I'll talk about, we're going to talk about one kind of workflow, and I'll take you through some other things that I'm doing with the material that you may consider. There's a lot of options available. So we're going to talk about mixing of the resins and how important that is. We're going to talk about the printers and printing of the material, cleaning of it once it's done printing, curing of that material, bonding it to whatever base you choose to bond it to, and then finishing of that. So we're going to kind of take you through that process. Mixing of the material I found is important, and it's not, there's, other materials that you have out there have nanoparticles mixed into it to give it some of its properties, and you have to mix those like crazy. I mean, there's some companies that you need to mix for an hour before or longer. This material is not that. Trusana, the chemistry of Trusana is as strong as it is because of its own chemistry. There's no additives. The material could be clear. There's no added particles to it. The only thing that's added is the pigmentation, and that pigmentation, we're doing denture teeth, needs to be accurate. And so that's where you can get some settling of the pigments if it sits for a long while and you need to shake it up. So here's kind of what I found. If it sits for a week or two, let's say it's an unpopular shade that you don't use all the time, I would give it an aggressive shake, with your hand, or if you have some machine that'll give it a good aggressive shake for a few minutes. And then put it on some sort of a roller. There's a lot of simple rollers out there that are for dental, but there's also, this is a hot dog roller. You'd go into 7-Eleven and you have your hot dogs rolling on there. You can get this on Amazon for 150 bucks or something. It'll hold 4 bottles of the material on there, and it just slowly rolls them. And so you could keep it, and I would say that if you have resins you use pretty regular, that if you just keep them on the hot dog roller, you come in the morning, start it, it rolls them. When you leave at night, turn it off. When you come in the morning, start it, it rolls them. You're going to keep those pigments suspended. That's fine. It's when they sit that you need to have that aggressive shake, where you really got to shake it up. Problem is you will incorporate bubbles. So you have to kind of plan, all right? If you're going to do that aggressive shake, I would let it sit overnight. You could put it on the roller overnight, because that will still allow the bubbles to find their way out, and make sure that it does release those bubbles before you print. So the mixing is important to make sure you do have an accurate shade. I've also found that if the particles really settle, so early on, years ago, when we were I was first getting samples of this Trusana material, the particle sizes were different for the pigmentation. There's a lot of things that weren't perfected yet, and they would settle much easier than what we have nowadays. And when they settled, which we didn't kind of know yet, I didn't know anyways, I printed something and it came out like 3 or 4 shades darker than the shade that was on the bottle. And I was like, what's going on here? And we were going back and forth, and he was like, oh yeah, your pigment settled out. I'm like, well, if the pigment settled out, why is it getting darker? You figure it should get lighter because the pigments are not in the resin I poured into my printer. So the chemists, and the great thing that we have those available at Meyerson, said, oh, what happens is pigments settle out. A lot of those pigments keep light from passing through the resin. And so they have to formulate the resin there's kind of like little micro deflectors that they'll put in the resin to make sure it absorbs the right amount of light energy so that it sets properly. And this is coming from a layman, so I'm just telling you how I understood it. And as a lot of that stuff settles out, now the resin becomes more transparent, the light can pass through easier, and I was essentially overcooking, let's say, the resin with each layer I was building. And that's actually why it got darker. Was because of that, not because of a pigmentation. It just got darker. So, it's all interesting and all new to all of us. But luckily, I've gone through all this nonsense. So hopefully, I can kind of share that with you guys so that if you see these things or whatever, you know that that's probably something of what's happening. So that's the long answer to make sure that you mix these resins nicely. Your hot dog roller type of an apparatus should keep the particles suspended just fine if it's a resin you use pretty often. You know, if you pour resin into a vat and you tend to you can let the resin sit in the vat. Again, if it's a popular two shades you're using, like an A1 or A2, you can use your rubber spatula or whatever system you're using to mix in the vat that resin. And if you think you mixed it up, mix it a little bit more, because it is important that that's mixed properly to get a proper shade. But if you have any doubt at all, go ahead and pour that resin out of the tray, get it back in the bottle so that it can go on the roller. And then later on, when you actually use that shade, it'll be mixed properly and you'll get a really nice, accurate shade. Of the printers, you know, we have a Sega, we also have Sprint Ray, validated, and are doing really, really well. I have a Sprint Ray and a Sega, and you know, I haven't had any catastrophic misprints. I've had a few prints here and there where I had little pockets or something that showed up. It could have been me, probably was me, maybe a little particle of resin that flaked off or something and caused an issue. But like, I have more misprints with my model materials than I do with Trusana. It's a very fluid resin, and I think that helps. Again, that's a layman. I just feel like it's a much more trouble-free resin than a lot of other resins that I'll use in my machines. Milling. So you can print and you can mill a base. And that's all, you know, fine right now. We'll hopefully get to the point where we can print everything. And I don't think that's too far off, but milling is an option. Milling, we know, you can get accurate results. Milling can be a challenge with some extreme undercuts, with definition in the sockets, but you can have a really good result. And we know acrylics work, and traditional acrylics are pretty much what these pucks are made out of. So I think, you know, you're in good shape. But, you know, milling is time consuming, and depending on your volume, you know, printing probably is going to wind up making the most sense. This case here, depending on the mill you're using, could be in there for several hours, as well as this was in for several hours. The difference is I got one denture base out of that several hour time period, whereas in this case, I have 7, 8 dentures that can be done. So, you know, that's where we would all hope to kind of get to as far as volume is concerned. And I think we're getting there. There's definitely some materials available now. I think there's going to be so much better materials coming in the future, but you do have that option. You know, as well as teeth. Teeth, of course, don't take up as much space, but this is all the sets for all those dentures, right? So 8 different sets of teeth ready to be placed. I like to do them in quadrants. You know, some people like to split them even in the centrals. It just helps for fit. It helps in design, making sure that they drop down into those sockets easily. That's all I'm learning. I mean, also here, since this picture, I've started to flip these all upside down, let the anterior region of the denture be down, and just found that the supports tend to be less. You know, you always got to think anything unsupported has to have a support that comes up to it. And in this angle, there's a lot of support that's needed. Whereas when you flip them upside down, everything's kind of curved up, and the layer previous that's placed supports the next layer. So it's hard to think that way, but I've found myself more and more, like, my mind's starting to work to where I can kind of think about positioning those in the best way so that there is less unsupported material, and therefore you need less supports, and that we have better access for cleaning to all the sockets, and that's going to then give you a much more accurate fit of those teeth into those sockets once you start to put your 2 pieces together, if you will. Cleaning these materials is very, very important. There's residual resin left on the material. Now, one thing that's really nice about Trusana is it's very fluid. It's a very liquidy resin, and so it cleans off nicely. I was at a lab last weekend and doing a training, and we were dealing with a couple of other based resins, and they're very thick, very gummy, and Trusana is not that. So with Trusana, you're going to use alcohol to clean it right now. We're working on some cleaners that might be a substitute for that would be less harsh to the resin. The resin can be deteriorated by IPA, by alcohol. It's astringent. I mean, it is some wicked stuff. So I was talking to Dr. Snow White, who's working on a lot of our processing, and he had an analogy for me. He kind of broke it down and really made me understand it. He said with a resin and how alcohol reacts to it, if you can imagine that resin is a lot like a stucco house. So if you guys don't know, stucco is like the white houses you'll see a lot in California and places where it's really hot. And it's almost like a plaster, almost a combination between a plaster and a cement that they essentially smear on the outside of the house. And that is placed on top of some sort of a board, like plywood or something like that. And that plywood was nailed onto the frame of your house. And he said, if you can imagine when you place an appliance in alcohol, the alcohol eats away dramatically the stucco, right, of the house. This is, analogy. And it starts to eat through the board that the stucco is stuck on, and some of it gets into the frame of your house. And so what that does, it can dramatically weaken your appliance. So least amount of time that material spends in alcohol, the stronger appliance you're going to have. So my process right now, I've gotten it down to about 1 minute and 20 seconds to 1.5 minutes actually in the alcohol. So I'll have 2 of these units. These are an inexpensive cleaning unit. You probably have units that you received with your printers as well. You want 2 alcohol bath stations. You want a dirty one that's going to do the initial cleaning, and then you want a clean bath. So what I do right now is I'll put it in my dirty bath for about 1 minute, and that bath agitates. If you have an ultrasonic type bath, that's good. If you have just one that kind of agitates or makes the water swirl, that's good too. Once it's in there for 1 minute, I'll take it out. I'll go get compressed air and I'll blow on the surface. Now, alcohol evaporates very quickly when you blow on the surface, and you'll see that the surface will kind of be dull. If you start to see some wetting happen, like when you blow in areas and you'll kind of see this wetness kind of spread from there and it doesn't dry out, that's probably residual resin left over. And so what I'll do is I'll blow the sockets, I'll blow any very integral areas where I want to make sure that there's no residual resin left there. And then if I do see some of that, or whether I see it or not, I need to go to my clean bath, right? So if I see some of that resin, I'll go into my clean bath. I'll leave it in there for about 20 seconds to maybe 30 seconds. Usually I'll put in for 20 seconds, I'll pull it out and I'll blow again. And almost 100% of the time when I blow that time, I won't see any of that wetting happen, right? It'll be resin free, there's no residual resin. If there is, you can take a squirt bottle with some clean IPA in it and kind of hit those areas specifically. But it is very important that you get the material, all the residual resin off of that material, because that's just going to allow for an accurate fit. So that what you have in your hands is actually what you created digitally. It doesn't have any of that residual resin, because once you take that and you go to your light cure, it's going to take that residual resin, it's going to solidify it, it's going to set it up. And then that's going to be added to your denture, which will be your not exactly what you digitally designed. So this long answer that I'm giving to you for cleaning is to make sure that you spend as little amount of time in that alcohol as possible. Make sure that you don't have technicians that are going to leave it, go answer a phone, because you will have a greatly deteriorated appliance comparably to what you could have. And again, we are working on a cleaner. It's not released yet. It's a project we're working on that should allow for no concern or deterioration. And I'm sure it will tell you, you'll hear about it once it's something that's available. So that's the process that I use for cleaning. And I would definitely not leave it in there longer than 5 minutes, and just keep it in there for absolutely as short as possible. Once you know you got it clean, you feel confident, go ahead and light cure. We have settings specific for which printer you're using. I would not recommend. It's interesting that I found out that when you validate a printer, at the same time you're validating that printer's curing unit, and things can really get affected comparably between that. So if you go from an Asiga printer and then cure it in a different unit, you could actually deteriorate the appliance, possibly in fit, but definitely in shade. Tooth shades can get affected by being over cured, and of course strength can be affected by being under cured. So you really try to keep things consistent and really follow that instruction. So with the Asiga, for instance, it's 12 minutes, flip it, and then another 12 minutes. For Sprint Ray, it's 8 minutes, flip it, and that's another 8 minutes. Just has to do with the intensity of light and kind of how it was cured initially by the printer. Once you do that, believe it or not, this material also heat cures as part of its process. So a water bath. Now we have a lot of instruments in our lab that we can control a water bath, and that's fine. You just want to make sure that it's accurate about 80 degrees Celsius. I'll repeat that, 80 degrees Celsius. That's about 170 degrees Fahrenheit. I think it's like something like that. You want it to be accurate. You want it to be as close to that number consistently as possible. Again, this is a water bath that I bought off of Amazon. I think it was $100 or something like that. And it's digital and very simple to have. I take the appliance, put it in a bag. Direct contact with the water can affect shade and cause some problems. So we put it in a bag. You can get a Ziploc baggie is fine. Try to force as much air out as you can and seal it. Or if you have a little heat sealer in your office or something like that, put it in a little baggie, seal it up. That's what I do. And drop it in the water. So this beaker's off, it gets dropped in the water. This beaker has water in it as well. So it has weight, and then this goes on top because of course the bag's gonna have air and it's gonna wanna float. So we need to kind of push it down in. So that's how I do it. You could also put something heavy into the bag with it so that it kind of weighs it down and it sinks to the bottom. So however you go about it, you need it to be at 80 degrees Celsius. It needs to be in a bag, protected from the moisture, the water, and it needs to be, submerged. And it sits in there for 10 minutes. And that's so far with any system we've validated, it's 10 minutes in that cure. All right, so at that point, you will have a clean, cured set of teeth. At that point, you will have milled your denture base, you will have printed a denture base. Trusana does not have a denture base available yet. It is something that's developed. Matter of fact, those prints that you saw on that bill plate at the start, those are the Trusana material. It's just an FDA thing. So can't give you a definite on when that'll be available, but that's above my pay grade. I don't know when stuff like that with FDA and stuff is going to be available, but it is something that is in the works and you can look forward to in the future. So In this instance, you will process by milling a denture base, you will process by printing a denture base, whatever that might be. If you're printing a denture base, we find that Trusana is pretty accepting of bonding to a lot of different materials. So I would recommend that you follow the manufacturer of whatever you printed your denture base out of. Follow the manufacturer's recommendations on bonding. If you have some questions for us on a specific company, you can give us a call. We can give our experience if we have it. But acrylics bond to Trusana really nicely, so it's very accepting to that. So I've good confidence that you won't have many issues dealing with a composite bonder when you deal with primers or anything like that. But that is not a guarantee. It's just been my experience. If you process to a acrylic, then what I use this fusion liquid. Also found just prepping the surface of the Trusana with the burr, just doling it out a little bit or sandblasting it a little bit, and then just pre-treating it with some monomer with a Q-tip. Gives me a pretty darn good bond. I mean, no line of demarcation, but I have found this fusing liquid from Dillon Leach is a nice one as well. I'll paint it on, and it does a good job at kind of etching that surface or getting that surface ready to accept acrylic. And that's what I use to bond my teeth. Trusana bonds nice to acrylic. Your denture base, if it's milled, is most likely acrylic. So everything is going to bond. And you really won't even have a line of demarcation. There's sometimes with composites, you kind of get that little line right at the neck of the tooth. You get none of that whenever you do this. But just so you know this has 3 jars in it. 2 jars with the liquid and then a jar for mixing. The 2 jars with the liquid have a little medicine dropper, and you just draw out and you put 3 or 4, maybe 5 or 6, depending on how many cases you got, drops of each one into the mixing jar, and then you give it a shake and it sits for 15 minutes, and that's good for like 2 weeks. So you kind of mix up a batch of it and use it throughout the week or 2, and then once it's sat for 15 minutes, you can then paint it on your parts. Not a heavy coat, just a nice light coat, and then I use it on the sockets as well. It's just acrylic. It doesn't hurt, that's for sure. It really helps with the Trusana. This is what it looks like. All right, so you have your 2 medicine dropper and then your mixing jar. I have a little dapping dish for my acrylic and my denture base and teeth. So here I'll walk you through, again, just a light coat on there, let it dry. Same thing on the teeth. And then take your acrylic. I recommend that you filter the fibers out if you have fibers, or order an acrylic that is fiberless. They'll kind of show as little specks at the necks of the teeth. Also, the fibers could possibly cause a gap or a spacer in there, if you will, and cause problems. But I'll mix it up once it gets to, or really initially while it's still pretty liquidy, because you have sockets. I'll kind of just fill those sockets up. It's not really going to run anywhere. They're all their own little dishes to hold the acrylic. And then I'll kind of test this bowl and wait for it to kind of get to that toothpaste consistency, so that once I put the teeth down there, it's going to be less likely to want to run everywhere. A lot of times in digital design, we try to avoid letting those papillas really rise up in there deep, because a lot of times some of that will come out a little finicky and won't allow your teeth to settle in. You have to kind of do a lot of adjustment to them. And using a pink acrylic, and as long as it doesn't run, it'll actually fill that and take the place of that papilla. So that's why I like it to kind of come to that toothpaste consistency. It's not going to run everywhere. So once it gets that toothpaste consistency, I'll smush it down into place. And you can see you just kind of get a mushrooming or a bulging of the material. And then I'll take my Q-tip. Usually I'll wet it with a little monomer and I'll just kind of wipe over that joint, clean it up. Can't get it all, but try to get as much as you can, you know, to the, you know, off of the teeth. I mean, the pink will stick to those teeth, the Trusana. That's great. We want it to really bond well, but also getting it really cleaned off the teeth is also important, because then you'll have to deal with that later. And if you run over kind of with polish, you'll be able to kind of see that pink and realize you have a problem. So, you know, really wipe it down good. You could use, you know, some rubber bands. If you have an articulation, you could close it down, the articulation, to hold the teeth in place. If you wanted to create some sort of a matrix out of putty or something, you could use that. You do want to make sure that those teeth don't move. So, you know, there's a couple different ways you could go about that, but you want to keep those teeth in place and holding in place. And then you'll cure it in the manner that you would normally cure the acrylic that you're using. Once it comes out of the pot, this is what I do. This is not to say this is what you would have to do, but I'll take this burr, which is a little bit smaller than a number 8 round burr. So it's a little, probably 1.5 millimeters across, maybe 2 millimeters across. And I'm going to go around and I'm just going to remove the bulk of anything that's left. That's usually pretty quick. There's usually not too much, but being a nice big burr, I can kind of get rid of any of that area that might be bulky. Then I'll step down to probably maybe 1 millimeter to a little bit more than 1 millimeter round burr. And then I'm going to go around just to define that a little bit more. Again, it's pretty quick, just kind of giving it a once over at the necks of the teeth. Then I'll take a diamond disc and I'll slice the interproximals. You know, they come out pretty nice with some separation, but I like to define that. Now, here's the thing. If you're going to give this a high shine with pumice, I would recommend that you cut them just slightly deeper, right? Just to give it a little bit more of a definition. If you're going to OptiGlaze, the glaze will actually fill that a little bit. And so you can cut those a little deeper and let that glaze fill, and it'll give it a more of a, it'll still be filled so it won't collect stains and bacterias because it'll be filled with the OptiGlaze, but it'll still keep that depth because OptiGlaze is clear. So cut this, just give it a little more depth or a little bit more separation if you're going to polish it by hand, right? So that way you have separation, but you don't have food collecting in there and stains. If you're going to OptiGlaze, do a nice deep cut. And then I come in with this little itty bitty round burr. I don't even know the size, probably 0.5 millimeter or something like that. And then I'll kind of come off because you can't cut too deep down or you'll hit the base. And I don't like to cut these and separate these before I bond them because then that acrylic will want to run up in there and it's hard to get out. So as I slice this, you'll probably be able to go down about 3/4 of the way, but that last little bit you won't get. Well, this little round burr will let you kind of finish that off as you come down those necks. And anywhere else you want to define a little bit, this little guy works really well to do that. And then you're ready to high shine it. This is an example of a high shine, you know, pumice. Pumice works fine. I like using a brush with the pumice. You keep some of that anatomy and that differentiation. This kit works really nice as well. This is Meyerson's kit for polishing their flexibles. It actually works really good on their printed material as well. And again, because it's bristle brushes, it actually has the abrasive embedded in it. So with this material, again, the yellow is like your pumice and the red's kind of like your pumice as well. If I'm going to OptiGlaze, I'll go over it with the yellow, just kind of get any burr marks I might have put on and just get the surface, you know, smooth the way I want it. And then I'll go in it, but it's dull at that point. And I'll go over with OptiGlaze. But if you're going to high shine, it's yellow, red. That'll get all your major scratches out. Then blue and green, you almost start to shine there. And then you go over it with your rag wheel with a high shine. Most any Denture high shine works really nice. OptiGlaze, I'm loving more and more. Really love those kits. Again, I'll go over with the yellow. They also make a handpiece size. Those were for lathe size. This is for a handpiece size. Go over the surface, get it how I want it. And then, you know, I could touch up the color, you know, make the necks of the teeth a little darker. I could do a little blue on the inside, so I can give it a little red, a little off-white around the necks, remnants of the teeth to give it a little bit more of that blanched look. Really you'll see here in a second, can really customize these. And that's kind of what you can get. The Trusana has a lot of translucency to it naturally. And so it really takes the OptiGlaze, you know, more like a ceramic would. And it's not a ceramic, don't get me wrong. But what I'm saying is a lot of the materials that are available today, you paint an OptiGlaze on and it looks like you painted it on. It looks like it's sitting on the surface, which it is, but it doesn't look like part of the tooth. With the Trusana, because it does have a lot of translucency, it really takes the OptiGlaze on almost like Emax takes stain, where it really just looks like it's part of it because the Emax has so much translucency to it. And you can see here a little bit of the pale, a little bit of the dark red, little blue in the incisal, a little coloring around the neck. You can see how the OptiGlaze will fill that interproximal, so you get that depth of look, but it's clear, so that's why you're seeing a lot of that. And once you paint on your OptiGlaze and then you move to your clear coat, less is more. You could make that thing look like a marble, as shiny and as smooth as a marble. That's not the way natural things are. So a nice thin coat, really brush it out and spread it out so you don't get a little puddling and a super shiny surface. You just get a nice shine to it. Again, I went a little crazy and even stained the faucets and stuff. Not exactly necessary, but it is fun. So one thing I did want to share with you guys is the price. You know, a bottle of the material, and again, I'm not a salesman. This is just how I evaluate whether this material would make sense to be in my lab. But if you were to take an anterior and posterior set of teeth, $5, like that's like comes from China type prices, right? If you were to order 144 sets, because that's how many sets you can get out of a bottle of Trusana, that's going to cost you about $720, right? So you're still cheaper than what a cheap set of 144 cheap set teeth would be. You jump to mid-level, right? So mid-level range, I'm going to say at about $35. That's for a set of anterior and posterior teeth, right? You can get 144 sets again out of that at $35. That'd be $5,040. Right? So now we're way cheaper. And if we jump to a high quality, and I said $75, as we all know, that can get way higher than that. But I wanted to be kind of, you know, fair. Right? So $75 for an anterior and posterior set times 144 is $10,800. I would put Trusana in the level of functionality, probably above the higher quality teeth by the information we started with. Aesthetically, if you're just high shining it, I would put it in the mid-level range, right? Because it is a monolithic material. But if you OptiGlaze it, now you're putting labor in to OptiGlaze, but I think you're still coming out ahead, and I think you're at a level of a premium tooth at that point, as you could see in the previous slides. There's, you know, debates on different things there, and you can kind of settle in on where you would be with things. You know, there's some debate on how long OptiGlaze lasts. You know, I've seen studies where it's lasted a long time. I've seen it come back after a long time as well. And the way Trusana takes bonding to a lot of these materials, I think it's going to be a long-lasting option for it. But either way, all this information is for you to take in and you to evaluate where you want to settle, because you can't just give it a high shine and it is a pretty tooth, just as that. So I'd like to leave you with this. You know, in a lab, we tend to be a jack of all trades. And that's looked down upon. You know, I always heard this saying, jack of all trades is a master of none. And, you know, that's an insult. But did you guys know that that wasn't the whole quote? The whole quote is actually this: a jack of all trades is a master of none, but oftentimes better than a master of one. And so, you know, I wanted you guys to know, as you're sitting here listening to this webinar, learning about possibly getting a new piece of equipment you're going to have to learn, a new material you're going to have to learn, another trade that's involved in this industry, that, you know, it's a lot better than being a master of one. So, yeah, I think we're all doing a pretty good job, and I think we're extremely important and keep learning. All right, so now we can take a break and see if there's any questions that you guys have for me.
So Kris, we do have a question. Thank you so much for that great presentation.
Sure.
Does the trūsana particles separate, requiring shaking to mix before use?
So yes, but it's not the particle of the Trusana, it's simply the pigment that gives it its shade. So, we talked about at the start, getting a roller is nice to keep the pigment suspended, or you may periodically, if it sits for, week or two, to give it a violent shake with your hand, for a few minutes, really give it a shake, and then put it on the roller for a few hours before you then use it. And that's just going to get the pigments up. But the Trusana in itself will not change in its physical properties by sitting. It is the pigments that are used in the Trusana that you want to make sure are mixed thoroughly.
Okay, great. Thank you. There is a Q&A for everyone. If you'd like to click on that and ask a question, that's great to do for Kris. But right now, that seems to be the only question that I have. So thank you so much, everybody, for attending Zahn Academy today. Oh, we have another one coming in. Do you think that Trusana will open up to other printers?
Yes, for sure. They have other printers on the horizon right now that will be coming out, some very shortly, and then some, they're just kind of picking and choosing. It's difficult to do, because you got to understand, whenever they validate, they don't necessarily always change the printer settings for the material. Sometimes they actually have to change certain things in the material to allow for it to work best with that individual printer. And as we talked about, it's curing unit. So it's not a small feat that they have to just sit there and say, okay, well, here's how long it's going to sit on its burn set. Here's how long it's going to do. Here's what the lift rate it's going to be. Here's the lift distance. It's really gets into the chemistry and creating whole new batches of the material possibly. So they're kind of taking them one at a time. And we just released a SIGA like a month ago, I think it was. Before that, we had Sprint Ray. And then there'll be a biggie. I don't know if it's I can't really say, but a biggie will be announced and should be coming out very soon. So it's a big printer in our industry. And beyond that, they're got definitely, so the answer is yes. There's going to be many more printers available. They will try to get it validated for as many as possible, because that's only good business, to allow everyone to be able to use the material.
That's exciting news.
Yeah.
We have another one. Many texts say printed resins are not repairable or relineable. Do you believe this, or have you done this with this material?
Yeah, so that's the cool thing about Trusana. So I believe it. There are a lot of materials out there that are 100% acrylics. You put them on there and they just peel right off, right? Don't stick at all. Trusana is not that, right? Do not think that Trusana is the same as any other material that you've used in a printer. It is a different animal. Trusana went to a 3D printing show, like a trade show. This is not dental. This is, with Ford and Chevy and all these big companies that do 3D printing, and Trusana won awards there. This is a material that is, it is nothing like you've seen. So I bond acrylic to it. You'll see once you work with it, or if you'll work with it, that if you get a little on the tooth, you'll go to grind it off, and you'll grind and grind and grind, and you'll see it just kind of disappear. It never flakes off. It never just kind of it's bonded on, and you will grind it until it just kind of disappears. That we all do that in our industry, where you'll have certain things and you'll kind of grind on someone, it gets thin, it kind of flakes off because it had a little bit of a bond, but it wasn't quite bonded. No, it bonds to Trusana 100%. And I've done repairs, like I've been experimenting with the denture base, and I've done a few partials, and I've actually incorporated clasps into those partials, and then I had to repair them, right? Because it was a metal clasp. So I had to make a trench, and I had to set it in there. And when I bonded acrylic, I took the fibers out, right? So it's because we don't have fibers in something we print. And I couldn't see where one started and stopped. I couldn't figure out where it was. There was no line of demarcation. There was just no evidence. So my experience is it bonds pretty much like acrylic bonds to acrylic. So I've been very happy with that.